Hello everyone and welcome once again. In the last section we discussed about database services, and in this one we are going to talk about data analytics services. So let's look at the learning objective of this video. We are going to start with the overview of GCP data analytics services. Then we'll have a discussion around cloud PubSub, cloud Dataflow, cloud Dataproc, cloud Datalab. We'll also look at BigQuery. Then we'll have a demo on analyzing the data with BigQuery. And finally, we'll wrap up the section with discussion around use case of data analytics services. So let me set up the tone for this lecture by starting with data analytics services. So what does analytics mean? It's like analyzing or having a research on something, right? So we can say that data analytics include ingestion, collection, processing, analyzing, and visualizing the data, right? So you can say that it's a pipeline where you perform all this action on the data, right? And GCP has a comprehensive set of analytics services. So for performing all the actions on the data, you have maybe for ingestion, collection, processing. For every stage in the pipeline, the GCP has to offer some kind of a tool for analyzing and performing the task, right? So one of the tool is GCP PubSub, which is used for ingesting the data at a scale. So the PubSub model basically collects the data from some kind of sensors or from the logs, and it's based on the PubSub model, publish and subscribe. That means if there is any sensor that wants to publish the data, it will be publishing to a topic, and there will be an end user that will be subscribed to this topic. So whenever publisher or the sensor data changes, it will be published to a particular topic, and the end user who has subscribed to this topic will be able to receive the data on the real time. Now this can also be used for sending the logs to a particular topic. Okay. So the PubSub model is used for ingesting the data at scale, right? The next is cloud data flow that can be used for processing the data in the real time or batch mode. So sometimes you have a requirement for processing the data in the real time. For example, there is a Netflix which perform analytics in the real time what you are watching, and based on what you are watching it gives you a recommendation for the next show that you can watch, right? So for those cases you can use the data flow. The next is Cloud Dataproc, that is a big data service for running Hadoop and Spark jobs. So there will be some data which that will be very huge in number, or you can say historical data or legacy data. You can use the Dataproc for analyzing it by running Hadoop and Spark jobs, right? Next is the BigQuery, that is a data warehouse in the cloud, and it is used by most of the organization nowadays. So the BigQuery works on a very huge amount of data. Maybe it can be terabytes or gigabytes of data, and you can perform any kind of queries on that data within seconds that cannot be offered by any databases, right? So BigQuery gives you the advantage of running your query in very short amount of time on a big data set. And finally, there is a cloud data lab that is used for analyzing and visualizing the data. It means everything will be represented in the form of a graphs, and you can visualize the data what's happening in the background by looking at the graphs. So the cloud data lab is used for that purpose. All right. Now let's have a look at the cloud PubSub or publisher or subscriber. So it's a managed service to ingest data at scale. So as discussed earlier, any telemetry service will be publishing the data to a particular topic, and there will be receiver to this topic, right? And it's a managed service. So it's based on publishing and subscribing pattern. So somebody has to publish the data and somebody has to subscribe that topic for receiving the data. You can say that it as a global entry point to GCP based analytics services. So all the data that are coming to the cloud is first intercepted with this PubSub model, whether you have a telemetry unit or whether you have any logs or any kind of data that you want to send to the cloud. will be sent via this PubSub model. Right now, it acts as a simple and reliable staging location for the data. So you cannot think of it as a durable data store. Okay, you can think of it as a staging location where you get your data that is ready to be processed by some other tools of GCP like Cloud Data Store or Dataproc, right? Now, it's tightly integrated with services such as Cloud Store, Cloud Dataflow. So once you have the data in the staging location, there are receivers to this topic. This data can be received from Cloud Data Store, right? So Cloud Data Store will be subscribed to this topic, and Cloud Data Flow will also be subscribed to this topic, or any other application that has to process the data will be subscribed to this topic. And that's what it says, like it is tightly integrated with all these services so that it can receive the data from this staging area and use this for further processing. All right, now it supports at least once delivery with synchronous and cross-zone message replication. What this means is you get a highly reliable deliver mechanism, and it also adds redundancy because of this cross-zone message replication. All right, it comes with the end-to-end encryption, IAM, and audit logging. So all this mechanism gives you to secure your data and also monitor the inbound data coming from the PubSub. All right. So that's all about PubSub model. Let's move to the next topic, that is Cloud Data Flow. So Google Cloud Data Flow is meant for transferring and enhancing data either coming via real-time streams or data stored in cloud storage which is processed in batch mode. And cloud data source is based on the open source project that is called Apache Beam, and its serverless approach which automates provisioning management with serverless infrastructure and serverless computing. All right, you don't need to provision resources and scale them manually. Instead, you start streaming the data and connecting to data flow via PubSub, and it can automatically start processing the data and scale the infrastructure based on inbound streams. Okay, and the inbound data can be queried, processed, and extracted for the target environment. So data flow is typically used for manipulating data or pre-processing the data as it comes into the cloud. So the cloud data flow is typically used for manipulating the data or pre-processing the data as it comes into the cloud. The input for the data flow could be Google Cloud PubSub, while the output of the data flow could be written directly to BigQuery or Google Cloud Storage or to one of the manager database services like Cloud SQL. So the cloud data flow is tightly integrated with some of the other data analytics services like Cloud PubSub, BigQuery, and even machine learning. Okay. And there is a cloud data flow connector for Kafka, which makes it very easy to integrate Apache Kafka. Okay, so if you already have a Kafka infrastructure with the connector, it is possible for you to breeze Kafka with the cloud data flow and get the best of both the worlds, which is Kafka streams and cloud data flow, which is based on again Apache Beam. So this cloud data flow forms a critical component of data analytics services of GCP because the data that is coming via PubSub or Google Cloud Storage is being processed, manipulated, and transformed with the cloud data flow. So that's all about cloud data flow. Now let's move to cloud data proc. So it's a managed Apache Hadoop and Apache Spark cluster environment. So if you have application where you want to launch up Apache Hadoop or Apache Spark, you should go with the Google Cloud Data Pro. So it's a automated cluster management. That means you don't have to do anything manually. You decide you want to launch up Apache Hadoop cluster, you just go to GCP and just by a click of a button you can launch up a cluster which will be automatically managed. Now the cluster can be quickly created and resized from 3 to hundreds of nodes. So you don't have to worry about the scaling up and scaling down. It can be resized from 3 to hundreds of nodes within a very quick span of time. Now you can move the existing big data projects to GCP without redevelopment. So if you have a legacy project which is using the big data or any on-premise big data projects that you are running, you can easily move that to the Google Cloud Dataproc without making any code changes. Now it frequently updates the Spark, Hadoop, Pig, Hive and other components of Dataproc where you don't have to worry about the compatibility of the versions. It gets frequently updated. Now it also integrates with the other GCP services, Google Cloud Dataflow and BigQuery. So the data that is coming to the cloud, that is intercepted by PubSub, and output of the PubSub is input to the data flow where the data is getting transformed, and the output of the data flow can be input to the Dataproc where the data will be processed, and the processed data can be stored anywhere in the BigQuery or in any of the cloud database services, maybe like Cloud SQL. Alright, so that's all about Cloud Data Proc. Let's move to the next one, that is Cloud Data Lab. Now, the Cloud Data Lab is an interactive tool for data exploration, analysis, visualization, and machine learning. So, you can think of this Cloud Data Lab as a tool that is used for visualization of different data or matrices. It will be having different kind of graphs or in the form of a table or matrices. You can see different kind of data in the data lab, and it runs on a cloud engine and may connect to multiple cloud services. So a dedicated compute engine is assigned to this data lab, which will be having its own VM, and it may connect to multiple cloud services, maybe database services or machine learning services. You want to integrate it, you can directly integrate, and the matrix will be directly visible on this data lab platform. Now, it's an open source project that is built on Jupyter Notebook platform. So Jupyter Notebook is an open source project, and Google Cloud leverages this platform to make their own application, that is Datalab. Now it enables analysis of data on the BigQuery, Cloud ML Engine, Cloud Storage, and many of the other GCP services. You can directly integrate with it, and whatever you integrate, you will be able to visualize the data related to that service. All right, and now it supports Python, SQL, JavaScript languages. So I think it's pretty easy to understand what is the data lab, and that's all about the data lab that we'll discuss in this lecture. So now let's have a look at Google Cloud BigQuery. So it's a serverless, scalable cloud data warehouse. Serverless doesn't mean it does not have server. It's like you don't have to worry about its infrastructure and scalability. It's all taken care by GCP. Like setting up the infrastructure, provisioning, scalability, all those things will be taken care by GCP. Now it has an in-memory business intelligence engine and machine learning. So the task that you are performing with the BigQuery, it has capability of machine learning and perform some business intelligence operations that can be used for understanding what's happening with the data that you are feeding. Now it supports ANSI SQL dialect for querying. You don't have to learn any new languages for using this BigQuery. Only the languages that you already know for querying the SQL database, like select statements with some join clauses like inner joins, outer joins, or group by, can be used for querying the datasets. It supports federated queries that can process external data sources. So it means that it can pull the data from cloud storage, cloud bigtable, or any other spreadsheets that's there in the Google Drive. So you don't have to worry about where the data is coming from. You can pull whatever the resources you have in GCP. You can pull the data from those resources using some simple SQL queries with the join statements and group by statements. All right, automatically replicates the data to keep 7 days of changes. So it maintains a 7 day history. So you can go back in time and you can see what all the operations you have performed in the last 7 days on any data. You can see it, you can replicate it, you can make changes to it. That's one of the key advantages. Now it supports data integration tools like Informatica and Talend. So these tools are very widely used for machine learning, and performing business intelligence operations. So you can very well integrate this BigQuery with these two tools. And if you look at the bigger picture, it has a very huge use case. So it's time for us to look at the demo using BigQuery. So here once again we are on to a demo section where we are going to see a demo on the BigQuery. We will use a public data to perform some actions using the BigQuery. So we are onto the Google console here, and in here you will type the BigQuery in the search bar and will find this BigQuery link. Now we are onto the BigQuery console where you can see the BigQuery and you will get a dashboard like this. So in here there is a workspace and you can write your queries in here. And in the section in here you can see the personal history, the project history, and the saved queries. You can see it here, right? So now what we are going to do in this demo is we are going to perform a query on a public dataset, that is Stack Overflow. If you are aware about the Stack Overflow, you might be aware that it's a forum for IT engineers where you ask a question and somebody replies for your question, right? So the users who ask the question and the users who answer for your questions, they get a badge. Badge is based on the number of good answers or the good questions that you have asked. The people will upvote you. You will get the badges according to that, right? If you want to deal with huge amount of data, you can use this BigQuery for running any kind of query that takes longer than usual. Okay, so you can very well go ahead and add your projects in here, or you can perform any kind of query on the public data that is available to public, and you can also add some external data sources for running your queries. So in this case we don't have any project that is having a huge amount of data, so we will go with the public data set. When you click on this public data set, it will open up the public data sets that are available for free for your practice purpose or for your research purpose, right? So in here we are going to perform some operations on Stack Overflow. Stack Overflow has given its data for the public use, and you can very well go ahead and use this Stack Overflow data view dataset. This will open up a new window, and in that window you will be able to run your query. So I have got this BigQuery public data, right? And this data is basically coming from your Stack Overflow. Okay. For testing purpose, we have written a query that will run on the dataset that we just imported, the Stack Overflow dataset, and that will basically find out the users who have got the gold badges and how many days it took for them to get that badges. And we have also limited the number of limit to 10. That means that the top 10 gold badges user will be displayed and how many days it has taken for getting those badges, right? Let me copy the query and go to my BigQuery screen, and in here I will go to the editor and I will type my query in here. I will give the link to this query in the description. You can find it in the description, or you can also find it on my website given in the description. So I have written the query. Now I am going to run this query. If you see here, this query will process 1.7 gigabytes when it runs, right? 1.7 GB is not a joke. It's a very huge amount of data that our query is going to run, and we will get the results. And we have got the results within 0.0 seconds. That's because it's cached. So this is one of the advantage. I have run this query before and it took me 3.2 seconds for getting the data for the first time. If we consider this 3.2 seconds of time for running over 1.7 GB of data, that is unbelievable. And also if we are performing the same query once again, it is cached. So this is the best advantage of BigQuery, right? Now let's see what we have got in the result. So these are the badges, the name of the badges. First gold badge, and the famous question badge, the number of users are 3,81,000 something, and it took 1565 days for getting this badge, right, to this many users. Now similarly there are other badges, copy editor, great question. So all these data we are getting it from Stack Overflow, and that too within milliseconds. And that's a very big advantage of using this big data. All right. Now after the demo, it's time for us to look at the use cases of Google Cloud Analytics services. Now the first one is the Google Cloud PubSub, which performs very high speed ingestion of data. And wherever you have a sensor data or telemetry data or the logs that are coming in, you can use this PubSub for ingesting the data to the GCP. Okay. Now the cloud data flow, it can be used for stream and batch processing. So the data that you get from the PubSub, that can be used for ingesting into the cloud data flow, where it can be used for performing business intelligence and machine learning operations. So this ETL here stands for extract, transform, and load. The next is the Dataproc, which is basically used for the math reduce jobs, and it is widely used with Apache Hadoop and Spark. So use case can be the map reduce jobs. Now the Datalab, basically that is used for visualization, and it is basically based on the Jupyter notebook for interactive analysis. So it's very well integrated, and it provides better visualization to the data that you are ingesting. Now the BigQuery that we just saw in the demo, that can be used for business intelligence or machine learning also. So you can perform any kind of SQL queries on the data and get the required data out of it. So these are the use cases of all these services, and I hope that you have understood most of it, how to use it, where to use it. So that completes the section on Google Cloud Analytics platform. If you are not subscribed to my channel yet, I request you to please subscribe, like the video, and if you have any doubts or video suggestions or feedbacks, you can just write it in the comment section. And if you provide us a feedback, we will be very happy to improve our content based on the feedback. So that's it from this section. Thanks for watching.